Now we're going to look at the answers to group investigation number 2. In question number 1, it says let f of x equal x squared, g of x is f of 2x, and it's important to note that the 2 is on the inside. So please add that as a note at the top. And h of x is equal to 2 times f of x. Here, we're multiplying by 2 on the outside. So this is all about the difference between multiplying inside versus outside, which is a difference between horizontal or vertical scaling. Remember, at any point when you're watching this answer key video, you can stop so that you can add details to your notes, as well as check answers, and then just resume the video when you're ready. So for part A, they wanted you to write g in terms of x squared. So because g of x says you're going to take f of 2x and the 2 is on the inside, then it needs to go inside parentheses and the squaring should happen on the outside. So g of x equals parentheses 2x, end your parentheses, and then square it. That's not the same as you see I wrote over here on the right-hand side in blue as h of x, where we're multiplying on the outside. If it's on the outside, you're just putting a 2 in front, and h of x is 2x squared. Now remember, you have a thing called a parent function, which is the bare bones of that type of shape. For this one, it is f of x equals x squared. That would be your parent function. So here's your table of values. I would assume that you are continuing to go to your graphing calculator and doing it that way. You want to type in g of x equals parentheses 2x and parentheses squared, and h of x equals 2x squared to get your table of values. Now in the table, I added a couple extra things that you might want to add. Because we had space on the graph, I actually added 416 and negative 416 to the f of x equals x squared, which again, you also have on your graphing calculator. For g of x, I wanted to show you how this was happening. Because the 2 is on the inside, that means the input of x, which is negative 3, is getting multiplied by 2 first to get negative 6 before it is squared. You can see the same thing in the next one. The input or x value of negative 2 is being multiplied by 2 first before it's being squared to get 16. And then I didn't continue, but that's the same thing that happens through the rest of the chart. When you look at h of x, this is just 2 times the output. So when we look at f of x, the output for negative 3, or the y value, or the f of x value, was 9. All we have to do is double it to get 18. And that's how all of the pink values were arrived at if you think of it without using your graphing calculator. So now you have all 3 pictures on the graph. Make sure you have everything labeled and you have arrows. Now we can go down to the questions. D, how does the graph of y equals g of x relate to the graph of y equals f of x? So because the multiplication happened on the inside, it is horizontal. And because it's inside, it acts opposite, just like it did when we were adding and subtracting. So remember, when we added on the outside, we went up. But when we added on the inside, we actually went left. It acts the opposite when it's inside the parentheses. So because it's inside, it's horizontal. And because it's a 2 on the inside, it's actually a scale factor of 1/2. So the x value was divided by 2 for the same output or y value. In E, how does the graph of y equals h of x relate to the graph of y equals f of x? Because this time the 2 was on the outside, it's a vertical, and because it's a 2, it's a stretch. So it's a vertical stretch of a scale factor of k equals 2. Now, k is just the letter they use to represent the scale factor. Here, it's the y value that was multiplied by 2 for the same input or x value. Now, how are the values of f related to the values of g? If you look at your values for f and your values for g, f is 1/4 of g, or you could say g is 4 times f. So the reason that's happening is because if you go back up here and look, the 2 for g of x is inside the parentheses, and if you actually do 2 squared, it's 4. So that's why they're either 1/4 or times 4 apart. For how are the values of f related to the values of f, the value of f are half of the values of h. That's because we doubled on the outside. So you could also say h of x is double f of x if you looked at it backwards like that. Now moving on to number 2, Our parent function, f of x equals x squared, is the same. And we have one other function, h of x, where we're going to multiply by 1/2 on the inside. So pay attention to that. Because it's on the inside and we're multiplying, it's going to be a horizontal scaling. So when we write h of x, it should be equal to 1/2 x on the inside of parentheses and then squared. So you can see your values there for h of x that we obtained by using the table of values. If you have decimals that are equivalent, that is okay. When you look at your picture over here, make sure you have your arrows and your labels. And now we can go on and answer the first question. C says, how does the graph of y equals f of x relate to the graph of y equals h of x? So because the 1/2 was on the inside, it's horizontal. Because we're multiplying there, and then we're going to have a stretch because it's on the inside. It's really by a scale factor of 2. The x value was divided by 1/2. How are the values of f related to the values of h? So if you're looking at those, you can see that the values of f are 4 times larger than the values of h. Or if you said it backwards, you could say the h values are 1/4 of the values of f. So just a quick note and reminder too, if we're thinking about comparing. If g of x were to equal 1/2 times f of x and that 1/2 was on the outside, then it would actually be a vertical shrink. So you can see how it works opposite when you're putting something on the inside versus when you're putting it on the outside. And we will be summarizing all of the transformations that we've learned at the end of this video. Now in number 3, the complete table of values for the given functions you need to make in part A, and then B says label each of the graphs with the appropriate functions from the table. So we filled this in, again, using the graphing calculator to get our values. And because the 2 is on the inside for the teal, it's a horizontal scaling. And for h of x, we're multiplying by a negative, so this is actually a reflection, which you can see when you look at the graph. If you look at the green and the pink, they are symmetrical to each other. They're mirror images of each other. They are a reflection. So in part C, describe the transformation that takes the graph of y equals f of x to the graph of y equals g of x. The graph of y equals g of x is a horizontal shrink. So again, if you look, it's a 2 on the inside, so it's the opposite. Inside means horizontal. It really means that you're shrinking it by a scale factor of 1/2. In D, consider y equals f of x and y equals h of x. What does negating the input do to the graph of x? So by negating the input, that just means you're multiplying by a negative. The graph of y equals h of x is a reflection over the y-axis of the graph y equals f of x. And again, this has to do with the fact that it's inside. Because you're multiplying by a negative on the inside, we're not reflecting over the x-axis as we've seen in the past, we're reflecting over the y-axis. So that concludes the group investigation part of this. So now we're going to look at the summarization chart that is actually at the start of your day 4 notes for 4 interesting transformations of functions. So please, if you could, find this page in your notes. You should just be able to turn to the next page, and you're going to see a summary of our recent transformations. We're going to find or write examples from our investigations for each description. So there are many things that are already filled in. All we're going to do is make some extra notes here as a summary to kind of finish out our video after our last investigation. So first, we want to talk about the fact that the way this chart is set up is we have vertical on the left-hand column, and we have horizontal in the right-hand column. So this is a difference of whether things are happening outside or inside, okay? So if I look at vertical, this means the y values are changing. Whereas if I'm looking at horizontal and it happening on the inside, that means the x values are changing. So again, vertical versus horizontal. If something happens vertically, that means that the k is on the outside. If something is going to happen horizontally, that means the k is on the inside. Now, when we look at the next thing that we have here, we have translate here, which this is when we're either adding a positive or a negative k. So we add a positive or negative k value. Whereas if I look down here at scale factor of k, this is where we are multiplying by a positive or a negative k value. So translating is where we're shifting it right, left, or up and down. Scale factor is where we are scaling it by shrinking or stretching either vertically or horizontally. So now when you look at the rest of the chart, this is organized so that you can see the breakdown of what all the transformations do. So here we are adding a number on the outside. The difference is whether we are adding a positive or we're adding a negative, okay? So if we're having k is greater than 0, that means we're basically adding. Whereas if we are a number less than 0, you can almost think of it as subtracting. So if you're adding a number on the outside, you're going to translate up. If you're adding a negative or subtracting on the outside, you are going to move down. Now, the difference with what happens when it's on the inside is you actually kind of go the opposite of your instinct. So here, if the number is greater than 0, you're actually going to go left that many units. And if the number is less than 0, you're going to go right that many units. So that's important, the difference between it being outside versus inside. For scaling, we're talking about multiplying by a number on the outside. So if that number is larger than 1, it's going to be a vertical stretch by a scale factor of k. So if it's a vertical stretch, think of a ball of Play-Doh that you're pulling apart. Okay, so it's actually going to get taller and skinnier. If you multiply by a number that's between 0 and 1, so for example, 1/2, okay, you're going to have a vertical shrink. So that means you're going to squish it and it becomes shorter. Now on the other side, we have an addition of negative numbers. So here, just put a note that you're also dealing with negatives. So when we have a number between 0 and -1, you're still going to notice that vertical shrink. But because we also have a negative, we're doing a reflection over the x-axis because of the fact that that's on the outside. Similarly, if we have k is less than -1, so for example, -2, we have a vertical stretch still, but also a reflection over the x-axis because of the negative being multiplied on the outside. So here would be an example of like -1/2. Now that was all when k was on the outside. If k is on the inside, we have to look at it a little bit differently. On the inside, all of these stretches and shrinks now turn into horizontal stretches and shrinks. So here, when k is above 1, you have a horizontal stretch by a scale factor. So when we say horizontal stretch here, that means it's actually going to get wider. Okay? So then when you look from 0 is less than k is less than 1, so for example, again, 1/2, but inside you have a horizontal shrink by a scale factor of that. So this time you want to think skinnier. Now, just like before, these ones are adding in the negatives. And so if I multiply by a number between 0 and -1, so for example, -1/2, I'm going to have a horizontal shrink, but this time it's going to be a reflection across the y-axis because it's on the inside, okay? And then if the number is less than -1, for example, -2, you have a horizontal stretch, and it's going to be a reflection over the y-axis because, again, it was on the inside. So that concludes your video